What if AI could actually teach itself to get better? I'm not talking about some lone genius AI, but an entire team that evolves together. Well, today we're diving into a really cool new approach that does exactly that. It's completely changing the game for how AI learns, adapts, and grows.
Have you ever felt like most AI systems are kind of stuck? I mean, they're super powerful, for sure, but they also feel a bit brittle. They're great at their one job, but the second something changes behind the scenes, poof, they break. They don't really learn from their mistakes or get smarter on their own. Nope, they need a human developer to swoop in and fix things. And that is the exact problem we're going to talk about. So this really breaks down the difference between the old way and this new way of thinking. Over on the left, you've got your isolated agent. It's static, it's brittle. Basically, if the data it's looking at changes, it just fails, and it needs a person, a human, to come in and manually fix it. But on the right, that's the evolving group. This is a system that's built to learn all the time, to literally heal itself from errors and, operate with real autonomy.
And that really gets to the heart of what you could call AI's biggest blind spot. And that's the problem of learning completely on your own. I mean, just think about it for a second. You have this brilliant AI that's great at analyzing data right up until the database schema changes. And a schema is just a blueprint for how the data is organized. That blueprint changes even a little bit, and bam, the AI breaks. And that means engineers have to spend hours and hours manually tweaking and rewriting code to get it working again. It's this constant need for handholding that's really holding AI back from being truly adaptive.
Okay, so how do we fix this? Well, the solution is a pretty radical shift in how we think about this stuff. We need to go from learning alone to learning as a team. And this is where we get to introduce this incredible concept called groupy evolving agents, or GEA for short. So what is GEA? In a nutshell, it's a system where individual AIs aren't learning in a vacuum. Instead, they're all evolving together. They share everything they learn, all their experiences, into one big pool. So they're not just learning from their own wins and losses, they're learning from the successes and failures of the entire team. The easiest way to get your head around this is to think of it like an AI evolution lab. Okay, so picture each AI agent as a scientist. Now, in the old model, every scientist is stuck in their own little lab, not talking to anyone. But with GEA, it's like they're all in one giant open lab, and they share everything. Every single lab note, every experiment that worked, every one that failed, every tiny little breakthrough, it all gets shared. So what's actually in these shared lab notes? This isn't just a bunch of random data. We're talking about incredibly useful, concrete stuff, like query patterns that actually worked, common failures that everyone else can now avoid, brand new, clever ways to use their tools, and really important insights about the data structure itself. It's a goldmine of shared knowledge. Okay, so how does this AI evolution lab actually work? Let's break down this cycle step by step to see how these agents really do learn together. It's basically a four-step loop. First, the system picks a parent team of agents to learn from. Second, those parents throw all of their experiences into the shared pool. Third, the system chews on all that shared knowledge and creates what are called evolution directives. Think of them as a recipe for getting better. And finally, it uses that recipe to create a whole new generation of offspring agents. All right, let's look at step one, picking the parent team. Now, you'd think the system would just grab the top performer, right? The valedictorian of the AI class, but it's way smarter than that. It looks at Agent A, which, yeah, has super high performance, but it also looks at Agent B. Agent B might not have the best scores, but it has high novelty. In other words, it's the creative one, always trying weird new things. And that right there, that's the secret sauce. The system is literally designed to pick both the star student and the creative weirdo. And why is that so important? Because that's how you get real breakthroughs, by combining what's proven to work with totally new out-of-the-box ideas. If you only ever pick the best, you just get stuck doing the same thing over and over. You never find a dramatically better way. So you take this diverse team of parents, and they dump everything they've learned into that shared pool of knowledge, the good, the bad, all of it. The system then analyzes everything to figure out what works, what doesn't, and most importantly, why. It boils all those insights down into a solid plan for getting better, and then, boom, it creates a new, smarter generation of offspring agents who are literally born with all that collective wisdom. Okay, so this all sounds amazing in theory, right? But what about the real-world payoff? Does it actually work?
Let's take a look at the results when the system was put into action. Minus 72%. Just let that sink in for a second. That's a huge number. Any guesses what that could be?
That is the drop in recovery time when something breaks. The system learns to heal itself. So get this. In one test, a database update completely broke one of the agents. But because it was part of this evolving group, it was able to learn from another agent that had already figured out a better, more robust way to handle the change. The system automatically shared that winning strategy, and the broken agent's next generation was born with the fix already built in. It healed itself 72% faster. Incredible. This is such a perfect example of how the learning happens. An AI agent might start its life with a super simple, generic prompt, like this one. Just generate SQL for a user's query. SQL is just a language for talking to databases, so yeah, pretty bare bones.
But now, look at this. After only 10 cycles of evolution, check out what that prompt has turned into. It's unbelievably sophisticated now. It's learned to specify the exact dialect of SQL needed. It's picked up little tricks to avoid common errors, like how to handle dividing by zero. It's even learned super specific knowledge about the pharmaceutical industry's product hierarchies. And here's the kicker. No human programmer wrote a single line of this. The AI group taught itself all of this.
And the impact on the business side? It's just staggering. I mean, look at these numbers. With GE, query success rate shot up by 14 percentage points. The amount of time humans had to spend manually fixing things, that dropped by a whopping 80%. And, like we just saw, the average time to recover from an error also plummeted by 80%. This is not just some tiny improvement. This is a complete game changer for efficiency and autonomy.
Okay, so let's zoom out for a second and think about what this really means for the future of AI. What we're really talking about here is a truly self-improving system. There's a quote from the original research that just nails it. It says the GEA transforms a static tool into a self-improving platform that gets smarter with every query. That's it right there. This is a huge step. We're moving away from AI that needs constant babysitting by humans and moving toward systems that are truly autonomous. Systems that don't just do stuff, but that learn, adapt, and get better all on their own, continuously, and as a team. And that really leaves us with one final and pretty mind-blowing question. We've just seen how powerful this group evolution idea can be for one really complex problem. So if we can have entire teams of AI agents learning, collaborating, and evolving together, what are the really big, world-changing problems they're going to solve for us next?